Multiple forms of federation can be done between data management systems. Tightly coupled federations are a unique property of data grids. There are three forms of federation that can be used by data grids. Tightly coupled federations establish trust between two or more data grids, share namespaces, and support cross-data grid operations. Loosely coupled federations support direct access to external resources through web services. The user namespaces and file namespaces are not shared, and the only operations allowed are executed through web services. Asynchronous federations have their access mediated by a third-party system such as a message bus. Instead of interacting with the federated system, all requests are posted to the message bus. The federated system chooses when to process the requests and whether a response will be posted back to the message bus. Loosely coupled federation is used to interact with independent data management systems or service providers. Interactions are done through service calls. This is similar to interactions with a remote system through a broker. However, the protocol required by the remote data management system is generated by a microservice within the data grid to allow communication to proceed. No assumption is made that the remote system will use the same native communication protocol as the data grid middleware. No trust is established between the data grid and the external service. All required authentication is done at the remote system. In data grids, the knowledge needed for interaction with the remote system can be captured in a microservice. The microservice can be reused in a workflow, enabling interactions with the remote system to be integrated into rules within iRods. Rules still need to be created for interaction with each service. Rules still need to be created for interaction with each service provided by the remote resource. A data grid user can invoke rules to discover files, retrieve files, and apply a remote service, such as transform files. Files that have been retrieved from the remote service can be registered into the data grid. This type of federation is typically used to access public data and services provided as a public web service. As part of a National Science Foundation EarthCube grant, the iRods data grid was loosely federated with the Cyber Integrator technology at NCSA. Cyber Integrator manages submitted workflows, executes the workflows at a high-performance computing facility such as the Texas Advanced Computer Center, and retrieves the result files. The integration with iRods enabled the submission of workflows through an iRods rule, the monitoring of the status of the remote execution, and the registration of the output back into the data grid. Access to Cyber Integrator was invoked from an iRods workflow. Cyber Integrator then initiated the execution of a workflow. iRods monitored the status and then retrieved the workflow output. In this case, Cyber Integrator acts as a broker for managing workflow execution at multiple sites. A second example of a loosely coupled system is the integration of access to the Data One Union catalog from the iRods data grid, as shown here. Again, the interaction is invoked through a microservice in an iRods rule. A request is made to the Data One catalog for a list of files that satisfy a search. A collection is made in the iRods data grid to store the files, and the files are retrieved using the Data One web services. The files can then be used in other workflows within the iRods data grid. The rules used to manage access to the Data One site are shown here. The main routine uses two input parameters, star keywords, which is a set of keywords describing the data sets, and star base call, which is the collection in which a result subcollection will be made. The rule makes a collection for housing the files that will be retrieved from Data One. The name is created from an input value, star base call, appended by star data one, the keywords, and a timestamp. A function cnSearch is called to retrieve a list of identifiers from a Data One coordinating node. For each returned identifier, an XML file is retrieved. The function cnSearch uses the keywords to create a request to do a search. A Python script is called to interact with the Data One coordinating node and issue the request. The results are retrieved into a variable called standard out. The function to get the XML descriptions for each identifier is called cnget. This creates a target file on disk into which the results will be written. A curl command is used to issue the request to data 1. Several ancillary functions are used to simplify the workflow. The getFilePath for obj function generates a query to retrieve the data path for an iRODS file. The URL encode function calls a Python script urlencode.py to encode a string. The function also strips a trailing /n from the output. The URLEncode plus function calls the URLEncode plus py.py Python script to encode a string. It also strips a trailing /n from the output. Take 7 minutes to complete exercise 114. Identify remote services that would be useful to your collaboration. Can these services be accessed through a web service? Can the web services be accessed through a rule? Please load a paragraph describing your result into the lifetime library in the sub-collection class INLS 624 by the end of today's class.